So this is an introduction to object-oriented programming with Python. So we'll be talking about object-oriented programming with Python, classes, objects with Python, OOP. So what is object-oriented programming? So object-oriented programming is defined as a method of implementation in which programs are organized as a cooperative collection of objects, each of which represents an instance of some class, or whose classes are all member of hierarchy of classes united using inheritance relationship. So what do I mean by this? Now, I say it's defined as a method of implementation in which programs are organized as a cooperative collection of objects. So programs now, they're organized as objects. They're just collections of objects. And each of these represents an instance of some class, which means, okay, now, a class and object, they are quite the same, but they are different. You understand? An object is an instance of a class. A class is just an abstraction that gives definition to these objects. I give common attributes and structures of or behavior to these objects. And whose classes are members of hierarchy of classes using inheritance relationship. So I can have a class person now. So this class person now, inside this class person now, I can have an object there, which is this person or that person, or I can say person 1, person 2. And where inheritance will come in now is when I have another class called student. And this class called student is having the same attribute or behavior that a person has, which is walking, talking, eating, or running. They have the same attributes, but I still expect this class student to have separate attribute that is specific to this class called student, maybe studying, or a variable called favorite teacher, and something like that. So these are attributes that are specific to this class called student. So what I'm trying to say is that let me make it clearer in this way now. So I can just say that I can have a class student now which represents characteristics now common to all students. So my class student represents characteristics common to all students. So identify a particular student in this class now. I will speak of this student or that student. So in the context of OOP now, which is object-oriented programming, we define class as a set of objects that share common structure and common behavior. And an object now in OOP is an instance of a class. So how do we go about defining an object? What are the syntax for specifying a class? So the first thing we need to do now is we want to define a class name. So that's the first thing we're going to do now. We're just going to come up with a class name. That's the first thing we need, a class name. So I'll come up with a class name, a keyword class first, then followed by the name. Then the next thing, if I want this class to have a variable, I will have a class variable. I'll have a class variable. Then what do I mean by this class variable? So class variable now is optional and it contains variables. Just like class variables, it can just be like name, count, especially count. We mostly work on like count. So now there's only one copy of class variable for all the objects that are created in this class. So now only one copy of class variable is created and is initiated when the class is loaded. So when you start a program during runtime, only one copy of that variable is created. So class variables are shared now for all the objects, which is the instance of these classes. So one particular use that we use class variable is to keep track of the count of objects. In such case, just like the count will keep increasing whenever we have a constructor, or whenever we create an instance of a class, and it can decrease in the destructor. So what do you mean by constructor and destructor here? So the next thing we can go ahead and create now is a constructor. And okay, let me just type constructor first. And what do I mean by constructor now? So constructor now is a special member function that is invoked automatically when an instance object of a class is created. So when you create an instance of an object of this particular class, automatically this function is invoked automatically once an instance of an object is created. This function is invoked automatically. This function called constructor is invoked automatically. You don't need to call it, you don't need to access it. So the next thing we want to call here now is we want to set members now. So you can just define method or members. So they are method in form of functions, or you can also call them members, right? So members now, member function of this class. So I just call the methods slash member functions. So now what are these now? So this contains the definition of member functions, and member functions are just like called methods in Python. This is a method that is defined that define the behavioral aspect of this class. So just like if I defined a class called person now, I can have a method called work there, right? That's def work, and I can print out this person is working. You understand? Then the next thing I can have here is, yes, it does not have to be one. I can have multiple methods, just like work, eat, run, and so on and so forth. Then the last thing I might want to have here is a destructor. Destructor is just like the opposite of constructor. Just as when constructor is called when a class is initiated, this is also executed when we delete an instance of a class. So these are the syntax that we use to write a class. So just take note of that, and you will understand this better as you work with examples with classes as we go on. So let's try and create an example of class and a program to demonstrate how class is used and how we can work with class. So I will just, okay, I have this now. So now if I want to create a class, as I said earlier, I need to start with the keyword class, right? Then I can have a variable, I can have a constructor, and I can have a member function and a destructor. So let's start with our class variable here now. I can have a class here now, and I'm working with class person. So this is class person now. Don't forget to end it with your column right here. So now I've created this class now, but now I want to create a variable to track the number of person I've created, numbers of objects I've have using this particular class itself. So I can go ahead and say count is equals to 0. So I'm setting this initially to 0 when there is no object, right? So I can now go ahead and say, okay, I can say I want to define a constructor right here. And a constructor now is just like the attribute I want this person to have initially itself. So having a constructor okay, when we talk about a constructor right here, what we use is a function, but we don't name this function anyhow. We use an init method itself. So function underscore underscore init underscore underscore. Yep, just like this. So the variables we want to have, the features we want to have for this function now, we can now define it as a parameter here. So I'll say go ahead and say name now. Then I'll set this to an empty string. Then I want to have age also. Set this to 0. Then what other attribute I want to have for this class called person? I want to have height. And I'll just set this to 0. Okay, 0.0 initially. Then I can just go ahead and say, now let me just print out constructor is, okay, let me say constructor invoke. So now I'm having constructor invoke. And I want this to be on a new line. So I'm having a constructor invoke, and now whenever this constructor is created, I want to call this class person, and I want to access this variable dot count, and I want to increase it by 1. So I'll just go ahead and say plus equal 1. So I'm increasing this variable now, and I can print out the current count of this class itself. So I can just go ahead and say current object count is, and just add person dot count right here. Then let's have a new line. Okay, instead of concatenating this, let me just use comma to separate this. Then I want to separate. I want to override what is separating them to be just an empty string instead. Then I can go ahead and set the name, have a variable that is specified to this class itself, to this instance itself, to name, then self.age is equals to age, and self.height is equals to height. So this is all I need to create my constructor for this class called person. And now if I want to create an object of this class, now I can just go ahead and say person1 is equals to, I'll call this person, but this init, this constructor right here, which is the init method, I need to put in these parameters here, the attribute of these parameters here, as an argument to this constructor, to this object itself. So I'll go ahead and say Andrew. Then, okay, let me go with 45 for the age. Okay, the age is an integer, 45. Then, so for the height, I'll just say 5.7. All right, so now I have an object called person1 right here. What if I just go ahead and run this now, so we can just see the output we are having right here. So here now we can see constructor invoked, because we are printing out constructor invoked, right? And I can see the current object count is 1. Then we exit the code itself. So you can see we have one person created, but what if I have 2 person right here? So I can go ahead and say person2, and I can go ahead and say person. Then I can just decide to say Paul. Then the age, I say 23. And let's just say its height is 6'1". And now if I should run this code right here, you see that now the object count for the second person now is person2. So I will teach you more about accessing this member, but before that, let's go to defining method. So we can decide to have some method called setters and getters, which I will talk to you more about in the future. But what they basically do is that setters method are used to just like get an attribute of these classes. Why setters are used to set the attribute of these classes. So I can just decide to say, go ahead and say print right here, self dot. Okay, I just say print person1 dot name. So I've created person1. I'm trying to print person1 name right, and you can see I have the name right here, Andrew, right? And if I go ahead and print person1 dot age, I'm accessing the person's age, which is 45, right? Which is what I set initially right here. And I can do the same thing as for person2, and I'm having the age. But setters and getters method as a programmer, I don't want to just be able to access the future of these classes outside the class itself. So I just want to have a method that will help me to access these classes itself. So I can just go ahead and say, okay, if I want to change the name now, I can go ahead and say this def name, but I'm able to change the name by just saying person1 dot name is equals to Drew instead. And now if I should go ahead and print out person1 dot name, you see that instead of getting Andrew, I'm getting Drew. You can see I'm getting Drew right, but I don't want to be modifying this outside the class itself. So I can just define some method right here, and I'll call it def name. Then not forget yourself, and I want to have name as a variable right here, as a parameter right here. So what I'm just doing right here is saying that self.name is equals to name. So instead of running it this way, I can just decide to go ahead and say person1.setName, and I'm giving it Drew instead. This is a setter method right here. It helps me to set or to modify the future of the variable here. And I can define a getter method too, which is just getName right here. Self getName. So I can just go ahead and say return self.name. So instead of accessing this person name directly, I can just decide to call the function getName and let the function do the work for me. So now I'm getting the name and I'm printing out the name. So that's what I mean by setter method and getter method, right? And we can also define some other variables that will just like do some other things. I'll just let's just say we want to display information here now. So I can just decide to have a function that will just display info right here. Then I'm just having self right here. And what I just want to do is to go ahead and print out the information of this person itself. And I can just go ahead and say print out name right here. And this is the name, and I'm just going to say self.name. So I'll just go ahead and copy this. Okay. Then now I want to have the age. I want to print out the self.age. Then I want to have, okay, height. I want to print out the self.height. So right here, I'm just go ahead and get rid of this. So I can just go ahead and say person1.display info. Then if I should go ahead and run this program now, you see down here we are having the information we asked for right here. You get what I'm saying? I don't need to print this out because I'm doing the printing in the function itself. So if I should go ahead and run this again, you can see I'm displaying the information I want. So this is just like the basis of class right here, and you can see how we identify this class, how we created an instance of this class. So now these are objects. This is the class itself, this class person now, and these are objects right here. So person1 is an object which is an instance of this class. Person2 is also an object which is an instance of that class too. So now let's talk about destructor. So there'll be an in-depth tutorial on constructor, destructor, getters and setters method with Python, but this is just an introduction to object-oriented programming with Python itself. So here what we just need to do is _, then del, which stands for delete. So I can just go ahead and print right here. Then let me just have a new line here, okay, a new line character here, and I want to say destructor. I want to go ahead and say destructor invoked. So right here now I'm saying that the destructor has been invoked, and now I want to make sure that this person's.count is reduced by 1. Then I can go ahead and print out object count left is. So just get here and say person.count. Then let me just separate this using, okay, an empty string. So how do I delete this object itself? How do I get rid of this object itself? So let's say when I'm done with a particular object and I just want to delete this object, I'm done with it, I'm not using person1 again, I can just go ahead and say, right here, I can just go ahead and say del person1. So if I should delete person1 right here, I can say right here, destructor invoke. So this is a destructor object, so I can delete an object automatically by using this destructor itself. And decide to go ahead and say how to delete person1 also. Then let's just run this and see. Now you can see destructor is being invoked and this object is being deleted itself. That will be all for this tutorial. See you in the next video. Don't forget to like and subscribe to my YouTube channel, Code Retro. See you next time. Bye.